afternoon to...
1 minute. We have to check. Vice Principal
Rajshekar sir.
Yes, he is there, sir.
He is there, sir.
Okay. Please.
Very good afternoon to one and all attending this International Alumni Lecture Series. First of all, I welcome our Vice Principal Admin, Professor Rajshekar sir, and our beloved HOD sir, Prabhu sir, for making this presence in this particular event. I would like to extend my hearty welcome to our alumni student, Mr. Prabhu Raidu, from 2012 to 2016 batch. Right now, he is going to work in as a project manager assist in Ensco Group Limited, Clevoyd, Bristol, and UK. And once again, I welcome all our faculty members for this auspicious event. So now I request our HOD to deliver the welcome address.
Actually, it's welcome address. It's by me.
Yes, sir. Yes, sir.
You have done the welcome address already.
No, sir.
On behalf of the department and management, I welcome one and all for this particular alumni lecture series. As I said before, there is one more session. Okay, I don't want to take much time. I welcome our Vice Principal, Professor Rajashekaran, and our alumni, Mr. Prabhu Raidu and Mr. Jai Ganesh, for joining us for this wonderful alumni lecture series. I hope this particular session will give a lot of information to the students, and it's like a knowledge sharing. And students, I request all the students to have to establish contact with the alumni, which is very, very important for your growth. As not that is even in terms of gaining knowledge, as well as in terms of getting some references for internship, placement, and even for higher studies. Okay. I also thank at this point I wanted to mention Satyaraj, Anthony Kashmiri, Imtiaz, and the entire faculty members for extending the support in conducting this particular international alumni lecture series. Okay, thank you. Now I request our respected Vice Principal Admin Professor Rajashekaran sir to give the inaugural address for this particular session.
Thank you, sir. Respected HOD.
It's a little bit low. Again, same thing. A little bit voice.
Oh, 1 minute, sir. Hello. Now it is okay.
Oh,
Again low only, sir. Again low only, sir.
Hello.
yes, sir. Somewhat better.
Okay. So, respected HOD Mechanical Engineering, Professor L. Prabhu, and the coordinator for the Alumni Lecture Series, Mr. Antony Kashmir and Satyaraj, Professor J. Sendil, and other faculty members, and today's Alumni Lecture Series by Prabhu Raidu. Hope you remember me. I have taken classes for you during this third semester. On behalf of the university and our institution, on my behalf, I welcome you for this wonderful
Thank you
session.
so much, sir.
The Department of Mechanical Engineering is doing a lot of initiatives and innovative things. They started the alumni lecture series in our institution, and thanks to this pandemic, and we are connecting more alumni through virtual medium. And under our Prabhu sir leadership, the department has taken a lot of initiatives during this pandemic also. Daily they are conducting one guest lecture series or FPP or alumni lecture series. Even they have conducted symposium. We are the one of the institution conducted a symposium during this pandemic. And we used to tell that for every institution, the 5 pillars are very important. They are telling that stakeholders. We used to call 5 pillars: the faculty members, students, parents, and employers. And the 5th pillar is alumni. So now I am very happy that the department is connecting more alumni through virtual medium and social media. We have started our social media activities 2 years before. Now our LinkedIn profile, through our LinkedIn, more than 2,500 alumni are connected in LinkedIn. So I'm very happy that most of our alumni are settled well in professionally, and they are in a very high position in all over the globe. And now we are connected, thanks to the social media, we are connecting through the various social medias like LinkedIn and Facebook. And I'm very happy to share that because of you alumni and our students, our Facebook page is one of the top 3 Facebook page in Chennai region. And we are the number 3, and we keep on posting our activities because we are conducting more number of activities compared to our regular activities. Now we are conducting more number of activities. This is the one example, like alumni lecture series. And I'm very happy to see that Jay Ganesh and other alumni are present, and they are going to take various topics in for benefit of our students. I request the students to keep in touch with our alumni, and they will share their experiences when they are studied here, and when now they are the experienced experts. And I request our alumni to visit once the lockdown is over, visit to our institution and give your inputs to improve our academic excellence. Thank you, one and all present here. Thank you for Prabhu sir for inviting me to address this wonderful gathering. Thank you. Thank you, one and all.
Thank you, Professor Rashid sir, for your nice words. Now I request Kashmir sir to introduce our alumni.
A short introduction about Mr. Prabhu Raidu. Prabhu Raidu completed his BE Mechanical Engineering in the year 2012 to 2016. He has done his post-diploma in Operation and Project Management in Madurai Kamarajar University, and he has completed his Masters in Mechanical Engineering in Sapienza University of Rome. He worked in Hitachi Automotive System as a graduate engineer trainee from February 2016 to July 2017. So during his MS studies in Rome, he has done his thesis on evaluating the maintenance, defect analysis, maintenance priority analysis, and he has designed a new predictive maintenance for the Mercedes-Benz in Bastiglia. Now I hand over the session to Prabhu Raidu to present the presentation.
Thank you so much, sir. Sir, I'm audible to everyone? Like, can everyone hear me?
Yes,
sir.
Prabhu. Yes.
Yes. Okay, sir, I'm sharing my screen now. So I would like to just give a small presentation about myself in the very starting. Okay, first of all, as Sir has given the introduction about myself, about my education and all, I'm very thankful. Like AVIT has provided me the very initial step for my everything of my career. So I would like to give a small introduction about myself, like how the things happen in AVIT and how I used to cope up with the things. So actually, it was really a great experience for me to be there, and mainly about the faculty and their face during our time, Mr. Ganesh Kumar sir and their face during the years of maybe from the first year to the fourth year, and all the faculty, they had really great cooperation to us, and it's been a great time for me. Not only that, and mainly about mechanical engineering department, and they have got like a very good rapport with the students, and not only that, they have always taken the initiative in arranging some of the conferences and something. So it is always a great opportunity for me to be a part of this very wonderful department in IVIT. So as far as my working experience is concerned, I worked for Hitachi Automotive Systems. I got this placement through AVIT. Actually, like in those times, we were the first batch to get selected for the Hitachi at the time. And it is a very initial company, like it is a greenfield company. So as far as my experience is concerned, I used to handle the injection molding department. So actually, this step has actually developed my career as well as my injection, like as far as my experience prospect is concerned. In Hitachi, I used to work with the injection molding machines to design the machines as well as to design the equipment. So, and this is a very great opportunity, and I always thank AVIT for giving me this opportunity. So, I will go to in depth about my experiences in this session, and I would as of now, I will try to give my best to tell you whether what are the things that we should do in a company, or like for example how to create a good maintenance performance system for a company, any company, let it be any company. So my thesis is mainly about designing predictive maintenance. Actually, let it be a company, let it be a company of production company, let it be a fleet maintenance company, or let it be any
Excuse
type of
me,
company.
excuse me, sorry,
So,
excuse me, sorry to interfere, Prabhu Raidu. You just go to the settings and please restrict others from annotating. That is doing annotation. Sam, please just guide him.
Professor, can you see that in top you have the share option? At the top, you can see the settings of Zoom.
yeah.
Yeah, at the end you can see three dots.
Yeah.
Uh,
Yes.
Can you see?
Yes, sir, I can see that, sir.
And can you
On three dots.
disable attendee doing this?
Disable participants annotation.
Yeah.
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 Okay. I think now it's okay.
No, please do it once.
Kindly clear the annotation. Can you kindly start the screen sharing again?
Yes, sir.
Yeah, please. Thank you.
Okay. Is it okay, sir?
Yes.
So as far my experience is concerned, as I told before, I used to work for Hitachi Automotive Systems, and I used to handle the injection molding machines. And actually, what the thing that we used to do is we used to develop the products actually in every manner. Let it be maintaining the tolerances, or let it be developing the supply chain, or it is like completely handling a project. So actually, this is a very good initiative for me to develop in overall. And later on, after leaving Hitachi for my higher studies, I worked for Ferrovie dello Stato Italiani, which is one of the biggest companies in Europe as far as the transportation is concerned. So actually, they provide the public transport for almost half of the Europe. So which is a very big company. And so actually, I would tell you how I got into this company and how the things happen here. So actually, as we all know, the maintenance is one of the main important thing as far as any company is concerned. So what I personally feel is uh, this lecture would at least give a good analysis about how to develop the things. For example, let it be going to a new company or a new production plant. How we have to do the analysis. So I think this would help you all. Actually, this is one of the research which has been appreciated all over the Europe, and actually I got a PhD, admitted for the PhD. So and I'm still waiting for the sponsor for this. So actually, this is a situation at present that is going on, and not only that, with the help of this research. With all the appreciation that I got it from this research, I got selected as a project manager assistant for Enso Robotics, which is a robotics company. They make the humanoid robots, and this is all about the project. And I would like to share the project for the benefit of the alumni if they want to know about this further. So actually, going into the topic, the maintenance, development, and predictions. So this is one of the best aspect what I felt as during my engineering. So because this is going to be a great initiative for any company, this is going to save the budget of the company. This is going to save the investment as far as the number of people are concerned, etc. So as far as this is concerned, today I would like to teach about lightweight transmission design through multi-object optimization and digital twins. So this is actually a very advanced type of project in which we'll be able to assess the things before literally seeing them. So actually, so I would like to give a small introduction about how I have done my previous project. So for example, if you go to a company, So the main thing is like we always should see about the historical data. For example, if you have a car, so you'll be seeing about what are the defects that are occurred in a car. For example, let it be the defects in the engine, let it be the defects in the suspension, brakes, etc. So what I have done is like I have divided my entire project into two things. One is a technical analysis, and the next one is an economic analysis. So what happens in a technical analysis is like we're going to take the fault data, so the data that we get from the human sources, the data that we get from the sensors, and sometimes the experience also matters. For example, the person with a 5 to 6 years experience will definitely have a good idea about how the things function and all. So I'm going to take the data. So this is what you should do. For example, if you're going to a production company, or if you're going to some companies, like let it be a manufacturing site or something. So you should be always taking care about the fault data. So the fault data will give a good analysis, and it will restrict the faults to happen again. So, and the next one is like I have thought that I should do a very good analysis, as which is a basic analysis. So what we should do is like whenever we go to a company or whenever you go to any job, so we should give a step-by-step analysis. So this is very important thing. So what I have done here is like I have taken the fault data, and the next one is I have done the preliminary analysis. The preliminary analysis will give about like the details about, for example, whether to do this or whether not to do this. So this will give a general margin. For example, imagine the company's budget is some 10 or 10 million. So let us imagine it is some 10 million. So for example, the benefits that we reap out from that is some 5 million. Then it is merely worse. Then and we should not go up with the project. So in those cases, like what we should do is like we should make a preliminary analysis. And if the preliminary analysis works out, then we should go to the technical analysis. That is what I personally feel that should be done for any of the projects. And this is how I have done for my project, the technical analysis. And I will go through about the analysis in the further slides to come, and I hope you will get a clear understanding about it. And the next one, what I have done is a cost benefit analysis. So like we'll have always a question in ourselves, like whether to start this project or whether not to start this project, or whether to pursue, let it be education. For example, if someone wants to pursue masters, so for example, the cost for masters, for example, for the fees or something like that, will cost some 20 lakhs. So if you're not going to get the 20 lakhs back, I don't feel that the investment is good. But like I believe that you get a good knowledge, that is something different. But we should read from that. At least, like for example, the engineering degree will finally like lead you to the success. The success in turn means money, which is what I personally feel. So the cost benefit analysis is a very important thing for any project. So I have done the cost benefit analysis. By following all these 4 steps, we can give the complete justice to any kind of project. So actually, this project is a 1 million euros project, and which is a very big project, which is handled by Mercedes-Benz in connection with Mercedes-Benz. So I have gone through all these 4 steps, and the project is very successful. And at present, they are actually implementing the project. So I would like to tell you how the things happen. Actually, like how I have developed the things. So it is very easy for the mechanical engineers because like you'll be able to understand this very clearly. So for example, this is a basic analysis that we should do if we go to any company. So what happens here is like, for example, this is just a general chart. Okay. So what happens is like these black lines here are actually the predictive maintenances. For example, the company is doing the maintenance at this time and this point, at this point, and at this point. So company is doing the maintenance here. So, but what the main problem that comes here is like here you can see at this point the defect is occurring just before the predictive maintenance or just before the maintenance should be done. And here you can see the defect is occurring just after the maintenance. So this is the biggest drawback for any kind of machine. So this is the preliminary analysis that one should do while going to a company. So let us imagine that you go to a production company, and so you have injection molding machine. So for example, you're doing the maintenance for every for every week. So and you are getting a defect at the 5th day of the week. So this is going to be a big disaster for the company because like they have to stop the production and they have to stop the service, and which is further going to cost, a very detrimental cost as far as the investment is concerned. So this is the preliminary analysis what I believe should be done. And the next one is a Bible analysis. Actually, the Bible analysis actually tells about whether the things are going good or not. So there are many types of analysis. So I have chosen the Bible analysis because this will give a good idea about whether to choose this or whether not to choose this. For example, uh, let us imagine you have a bike, and your bike it should give a mileage of some 50. So imagine it should be 50, but your bike is giving a mileage of 30 or 10 or 20, like little bit is getting low. So at that time, you'll be able to understand, okay, there is something defect with my bike. So how the defect is going. For example, this is the line. Imagine you have set up the line as like 50 kilometers, like is your mileage. For example, let us imagine like that for a liter. So this is your mileage, and suddenly what happens is like your bike is giving some 20 kilometers or like 25, sometimes more or sometimes less. So it is like not on this line. So you can tell that there is a defect. So there is a defect in the engine. So this is how like you can analyze a machine like not like just a bike or something like let it be a production machine. So the next one, what I have done is like I thought that I should be able to give a good justification for the project. So as we are engineers, so we should develop a technical analysis. This is what I personally feel. The technical analysis will give a good idea, and it always rely on proofs. So what the things here is like I have created a model. I will be sharing like how I have created a model and how the things has to be done. So I have implemented the model, which is one of the research by one of my professors, and I have injected this model into the system of Mercedes-Benz. So what happened here is like I will be able to easily analyze whether my system is working good or not. So in this case, what I have done is like I have analyzed this for a bus. So Mercedes bus. So what happens is like I have analyzed what is the current situation of the crankshaft inside. For example, whether the crank angle is good or not, whether the things are going good inside or not. So I have just given an idea about like, for example, like they can easily identify if there is defect in the piston. So they can stop the bus and they can check it before the piston gets completely ruptured or completely get damaged. So this is how a preliminary analysis should be done. Because for example, let us imagine you are doing the preliminary analysis or the technical analysis for a like an injection molding machine or like some kind of machine. So what we should be able to give is like we should check whether everything inside a machine is working good or not. So here in this case, I have checked the crank angle. This is a basic, and this will not give a complete analysis. So this is the first step of the analysis as far as technical aspect is concerned. The next step is always should be related to this technical aspect. So we should always arrange two or three different type of things to get a final thing. So here what I have done is like I have done a vibration. So imagine like whenever you are using like a car, and if there is some vibration inside the car, definitely there is some damage or definitely there is some thing that is happening inside the engine which is not supposed to be. So what I have identified is like in Mercedes bus engines, so there is some vibrations that which actually were caused because of the engine, the defects in the engine. So what I have done is like I have created a system for them to easily identify what is the defect. For example, let us imagine a engine. So it is having some shakes or it is having some detachments, etc. So definitely there is some defect. Like I can be able to easily identify that there is a defect in the engine by the vibration analysis. So I have created a system for the Mercedes-Benz to analyze the situation before the maintenance and after the maintenance. So I just don't want to go too depth into the technical aspect because this involves like a lot of time and a very detailed explanation. But I wish that this will just give a basic analysis. For example, in the very initial stage, we should do a reliability analysis to check the machine, and the next one is a technical analysis, and later on is always a very good technical analysis. Like in my case, it is the vibration analysis. So the next one, what I have felt is like, okay, for a car, we're just analyzing the engine, so which is not enough because the car has got a lot of parts and it has got a steering and it has got a suspension, it has got brakes, etc., etc. So what I thought is like the three main aspects as far as safety is concerned for every vehicle is the suspensions, brakes, and the engine. So this is what I personally felt, and which is more or less the very three important components of vehicles. So what I have done is like I have done a suspension analysis for them, and to tell that okay, if I'm you keep on using my suspension like this, for how many months or for how many uh, years is my suspension going to work? For example, if I'm going to apply the brakes now and then, so my brake pads will come for 60 days or so 70 days. So I should be able to tell that, because like if I'm going to tell that, like for example, my system is going to work only for 40 days or only for 30 days, then definitely I'll be able to justify the things and I will be able to do the maintenance. So this is how a maintenance should be done, which is what I personally feel for a vehicle. And the next one is the cost benefit analysis. Actually, the cost benefit analysis actually involves a huge topic of economic analysis and all. So, like, I would tell it very simply that I have created the three different formulas for a machine. So, the three different formulas tell whether to choose one thing to do. For example, you have got a bus. So, in that, you have engine, suspension, and brakes. So, if I'm going to do the maintenance only for the engine, then what is the cost? If I'm going to do the maintenance only for the suspension, then what is the cost? If I'm going to do the maintenance only for the brakes, then what is the cost? So, for example, if I'm going to do the maintenance for the whole system, then what is the cost? For example, if I'm not going to do the maintenance and if I'm going to buy the part from outside and I'm going to just fit, I'm going to do the nominal maintenance, then what is the cost? So this will actually develop the company's budget. So whenever you go to a company, the company always want not only want a technical aspect of a person, it always wants a cost benefit analysis. So we should be able to tell whether we should do this project or whether we should go away from this project, because the cost is which justifies, because nobody wants to take the risk and nobody wants to be in loss. So you should be always justified. For example, if I'm going to take up this 10 million euros project, so definitely we are going to reap some 15 million euros. So some 5 million euros will be the profit, or we are going to increase the services. Let it be anything, or even we are going to take the loss, but still we're going to increase the services. So this is how my thesis is all about. So as far as we are mechanical engineers, what at present what I'm thinking is like to broaden the things. For example, we should not go only to the technical aspect or only just general aspect. As we are mechanical engineers, I always believe in design. So why don't we start from the very starting stage? So why to do the maintenance by seeing the machine or like just taking the data from the machine or just doing the maintenance? Why to do that? Why don't we start from the very early stage of the design itself? So if we are going to design the things correctly, then the maintenance, like doing the maintenance is like something like we can reduce the maintenance schedules. For example, if you're going to design a thing properly, then definitely you need not do the maintenance like once in a week. You can do once in a 2 weeks. So what I felt is like I should be able to design a thing and I should tell that in how many months or in how many days my system is going to fail without touching the machine. So this is actually the main, we are entering to the main topic of my project. So which is actually like, we can tell whether my machine is working good or not without touching the machine. So this is a very interesting topic, and this topic involves digital twins. So for example, like I have created only for this presentation. Okay, so let us imagine we have a gate. So you have to design a gear, and you have to design a gear which is light in weight, and you should be able to tell like in how many days your gear is going to break without touching the gear. So this is a very interesting aspect because this involves design. This involves design, and you can easily identify. For example, you are going to use your gear for a month, and you can tell that your gear is going to get like your, for example, let us imagine today's date is 30. So you can tell on July 5th your gear is going to get break if you're doing if you're using it in the same way. So this is actually a very high level of prediction. So this is what at present I'm working on. So which is actually a concept of digital twins. So what happens here is like, let us imagine I have designed this gear. I have taken the material inside the gear. You can see here that I have taken the material inside the gear. So what happens here is like, I have reduced the weight of the gear. So which actually increases my efficiency, and not only that, which actually benefits in many factors. So what we should do is, like, we all know that we are doing analysis, we are doing analysis. Okay, this is all fine, but we should give a justification. For example, if I'm going to design a gear like this, so what are the conditions at this point, at every point of the machine, at every point of the gear? So I should be able to give justification. For example, at this point, if I'm going to face some defect, then my gear is a complete failure. So I should give justification on the whole thing. Like I should be able to give a design of experiments, or I should be able to give a response surface methods, etc. So we have got at present, in the present world, we have got a lot of softwares. We have got OptiSlang, we have got many softwares in analysis, etc. And not only that, in Python, we can easily analyze the things, and in MATLAB, etc. So we have got a lot of things. So as far as design aspect is concerned, I always prefer the OptiSlang, which is a very good software which actually gives a good response surface methods. So let us imagine like you're going to design a cell phone. So in the cell phone also, you can tell that like at what point my like it is fragile, or like, for example, at what point it would be able to sustain the force, etc., etc. So this is all about a gear. So like I just have made an example with a gear. So the next one is optimization. So design itself will not give a data, like data which is helpful for the manufacturing, or like which is helpful for a company to go. We should always give an optimization. For example, if I am going to reduce the weight inside a gear, then what is the effect? For example, like gear involves a lot of forces. So if I'm going to reduce the material inside, then what is the thing that I'm going to lose? For example, what are the benefits that I'm going to get, and what are the losses? For example, my gear should come for 2 months. Let us imagine. Let us imagine, like it will be more than that, but still, let us imagine my gear will do only for 2 months. So if I'm going to lose my gear for 1 month by taking the material inside and designing a gear by taking the material inside, and if I'm going to lose my gear in a month, then my project is a waste. So what I should do is, like, I always should give an optimization. So I should take on y-axis and x-axis. Let it be, actually this is a Pareto front. So what I have done is, like, if I'm going to maximize the power, so how much distance should I reduce? For example, like how small should my gear should be? For example, one of my gear is bigger than the other gear. So if I'm going to reduce the diameter of the gear, then what are the effects? So in cost, okay, I'm going to get benefited. So in everything is fine for that. But what about the quality? Am I going to get the same quality, or is it the same that the company is expecting? So this is how we should do a multi-object optimization. So what are the steps that I feel is, like, first of all, we design, we analyze, and we do the optimization. Actually, from the design comes the optimization. So you are going to design a car, or you're going to design a component of the car, and after that you're going to do an optimization, whether to develop the design, or whether to stop with the design. So for example, if I'm feeling that if I'm going to do this design, I'm going to a loss because of the different manufacturing processes that I have, like, because like manufacturing the gear is okay, but taking the material from inside and manufacturing like a gear, which involves a lot of equipment and all. So if my investment is more, then then I'm not going to go to that. So the multi-object optimization helps in this way. So what we should concentrate is, like, we should be concentrating on the variables. So I'm going to increase the teeth of the gear. I'm going to increase the module, face width, etc. I'm going to change everything. So I'm going to see the results. So we should always go like hit and try. Whether if I'm going to change this, what is the things that are happening? So if I'm going to change this, what are the outputs that I'm going to get? So this is the multi-object optimization that I feel. So the next one is a virtual model, which is actually which is called as a virtual sensor, which is a very high model of analyzing the things. So what happens here is, like, this is actually interrelated with the software. For example, let us imagine you have a good bike, and you are like, for example, going at 80 kilometers per hour, or like 90 kilometers per hour continuously, and keep on going, and you have to go from Kanyakumari to Mumbai. So this is the case. So you have to stop at a certain point, and you should be going like it, actually it cannot be a continuous journey. So what happens is like if I'm going continuously, for example, if I'm going continuously for some 300 kilometers, 200 kilometers, or something like that. So definitely there going to be an effect on the engine. So my project is like without touching the engine, without like going to a mechanic or like without facing the problem, I'll be able to tell, okay, if I'm going at this speed, so my if I keep on going at this speed for 1 hour, then definitely my tires are going to get ruptured, or like my brake is going to get failed, or like I should be able to get the signal much before that, very much before that. For example, like it is not like an indication. I should be able to get like, okay, if I'm going like this, then my brake will sustain for only for 15 days. Then it's fine. If I'm going like this, my brake is going to sustain only for 1 day. Then I won't be able to reach Mumbai from Kanyakumari. So what I'm going to do is like, okay, I'm going to maintain the things and I'll be able to go. So this is actually virtual sensor, which is a very high-end model, which is being developed in connection with the Predictic, which is a company in Germany. And actually, I'm actually in contact with them. So actually, like this is one of the projects that we are actually planning to develop. So what happens is like I am going to predict the things before the things happen. So by taking the data directly, like it actually is not like taking the data from the engine; it is taking the data from the design itself. I'm going to design it in such a way that before it manufacturing, I'll be able to tell that okay, I'm going to manufacture this gear, and my gear will be only sustain only for 2 months. So I'm going to manufacture the gear in that way. So this is a very good uh, like what we call an evaluation before manufacturing. So this is going to save a lot of money for every company. So actually this is a very good trend, and I hope like you attend some of the lectures on digital twins and developing the digital twins and like artificial intelligence and all, because like this is the future, what I believe. Because like it is not always the same to go into the work field and do the maintenance and come back. It's not always the same, because like you should change always with the new trends that you get. So what I personally feel is like at some point of your time, like at some point maybe after 5 years, what you will see is like you will go to the maintenance place, like knowing that the system is going to fail. So you will get the message before the system is going to get failed. So and you can take the measures and your maintenance work will be very less, and this is going to reduce the capital or the investment on the maintenance for any kind of company. So like, okay, this is fine. So I'm going to design that, and I'm going to tell, okay, my machine is going to fail and all, but there may be some defects in the software too. So what we should do is like in the very initial stage, we should take the data and we should actually analyze the data. For example, I could tell that, for example, with I will be able to set some two different marks. For example, and let us imagine for easy thing, let us imagine your bike, and I'm going to set that your bike should give a mileage between 60 and 50, and your bike is giving a mileage of 40. Okay, like then there is a fault. For example, if it is between 60 and 60, 50, then it's okay. So I should be able to check that. So this will complete a project. Like I'm going to check the design, I'm going to optimize the project, and I'm going to predict the project, and I'm going to finally check the final outcome that I get. So this is how I feel that I think that I'm not like that clear as far as this concept is concerned, because like with explaining things, but hope you will like keep on learning the for the years to come, because like this is what actually is the present mechanical engineering, because like we should be able to make the things easier and the processes easier. So finally, okay, this is all about the thing. So I don't want to go into this core topics, because like these are a complete different topics. Like these involve emission control and all. Because what I like, I just want to give a justification about this type. For example, if I'm going to change or if I'm going to reduce the weight of a component in a car or let it be in a vehicle, so definitely I'm going to reduce the fuel consumption. So like this is the analysis that I have done in Mercedes-Benz buses with the data that I get from the Mercedes-Benz. So what I have personally seen is like if I'm going to reduce some 50 pounds in any of the component of the engine, then definitely I'm going to reduce some 22.7 grams per kilometer. So this is, you're not only like like gaining the knowledge or doing the things that are supposed to do in company environment. You're also what you're also contributing something to the environment. So this is which is very much important as we are engineers. So the next one is whenever you go to a company. So this is all about the technical things that we have discussed previously. So this is actually the concepts. Let it be a FMEA, let it be a cost analysis, let it be a market analysis, let it be CRMs, ISO audits, KPIs, etc. So actually, like these are some of the things that you should concentrate, like in order to get a job. That which I personally feel, as we are mechanical engineers, so we should know the design, because which is very much essential, because I have faced some of the interviews and where the interviewer asks you about the design, because you are a mechanical engineer and he wants you to learn some CATIA, he wants you to learn some SolidWorks, analysis, ANSYS, MATLAB, Python, etc. So this is how actually the things happen. So what I personally feel is like you should have at least not, maybe not a very depth idea. You should have a basic idea about what is a PFMEA, what is FMEA, and how we are going to maintain the safety, and how we are going to do the cost analysis, and how we are going to do the market analysis, what is the KPI of the company, etc. So this is what I personally feel. And as an alumni of the Institute of Technology, so what I personally feel is you should be knowing at least the softwares, a little bit about the softwares, because like let it be AutoCAD, Creo, ANSYS, etc. Because when I have been to Hitachi for the interview, they ask me about the softwares, what about the software. Because actually they don't use the software inside, but still they ask, because they want to know that as a mechanical engineer, these are the kind of the key skill job requirements that one should have in order to get a job. So as far as career advice is concerned, it is always good to do masters, which I personally feel, because it's always good to have experience too. It's up to your choice, because you can choose masters or you can have experience. Of for example, our friend Jay Ganesh is having a very good experience. He has got some for 4 years experience, 5 years experience. So it's going to be a very good aspect, because in the further years to years, maybe you're an engineer now, and later on after 4 years you'll be manager, or you'll be an assistant manager. So you'll be gaining the knowledge. Knowledge gaining is one of the my very good aspect that I personally feel. But if you feel to gain a very good knowledge as far as your stream is concerned, let it be design, let it be automation, or let it be analysis or management engineering, etc. So what I personally feel is you should be doing masters, and the masters, it's all you feel it won't cost that much. Actually, I want to be very frank with my alumni, because you can get some scholarships, okay, because for example, I'm studying in Europe. So the fees is nothing. It is not even some 1 lakh or 2 lakhs. It's not even that if you get into a public university. But I do believe that the expenses mainly are maybe for your rents or for your accommodation, etc. But the thing is that rather than going to some of the countries, if you can afford, then it's totally good to go to some UK or USA or some other places. But as far as mechanical engineering is concerned, I found that Europe is one of the best places where you can find jobs. Like I don't find some manufacturing related jobs in America or United Kingdom. It is very rare to get a job in America or United Kingdoms with a mechanical background. So it is very good to get a job in Germany or Italy or Spain or somewhere around Europe or France, etc. So what I personally think is we should search for these opportunities. If it is Italy, then it's really good, because you will have a lot of scholarships, and you have very minimum fees, and you will have very good life. I can tell you that, because these are one of the biggest universities in Italy. Actually I graduated from Sapienza University of Rome, which is one of the oldest universities in the world, which is some 700 years old university. So which is a very prominent university. And if you graduate from there, imagine Marconi is from Sapienza University of Rome, and the barometer, the Rosselli is from Sapienza, and there are many presidents from Sapienza, prime ministers, the European prime ministers from my university. So it is always a very good opportunity to do the masters, and to to like develop your skills and like to expand your opportunities. So what I personally feel is like if you're willing to do the masters, maintain a good percentage, which is like a basic requirement for any of the universities to give an admission, and like apply for scholarships. This is I applied for a scholarship. So what happened is like when I was applying for this university, I got a letter from KV Sasiri sir, who was our HOD at that time. So he has been like very kind to me, and he has given a reference letter for me. So what happened is like the reference letter really helped me a lot, and I got a scholarship, and I got 2 projects from the companies, and I got like a very huge amount of scholarship, and I got my university fees covered in that, I got my accommodations covered in that, and I got 2 different projects, and I got a job, and which is the most important thing that I would say. And really, the AVT has helped me a lot because like they have given the recommendations for me, and I'm really thankful to Diwakar sir at the time, and really they have, and really I'm very happy to for all the cooperation they have given me, and like it's really great to be in contact with people. So like okay, this is fine. Like doing masters and all, this is a different aspect of life. For example, if you are willing to apply for jobs, what I personally feel is like go to LinkedIn and create a profile. Go to LinkedIn and keep on applying for the jobs. Like create a better LinkedIn profile for yourself. For example, you should mention the conferences that you have attended. Like don't take the conferences light, because like when we were in AVIT, we have taken the conferences light very well. So you should not do that, because like the conferences actually matters. So like sitting in the corner of a hall and like just clearly imagine like what they are telling and what the things that are definitely they are going to be very helpful, because like don't neglect any conferences that happen like in your AVIT, like because like this is gonna develop your resume. So like not to make your resume restricted for 2 pages or something like that. So you should stand out, because like it is very hard to get jobs in India, mainly because not only in India, in Europe and all in the world, but like you should. What I personally believe is like you should develop a good LinkedIn profile, because most of the companies hire from the LinkedIn. And I'm very happy that AVIT has got a very good placement. So I believe that many companies do come and people choose like AVIT in the years to come. Like not only that, like I wish that AVIT should develop the collaboration with the companies. So this is going to benefit the students of the AVIT. So what I personally feel is like LinkedIn and Indeed jobs, time jobs, and I believe there are some consultancies too. But yeah, so I wish the students will get benefited by things. And I think yeah, I think they are always maintain like the mechanical engineering staff always to support us, and I hope this seminar is like at least like a little bit engagement for you, and I hope to connect with you people in the further years to come, and I'm very happy to be connected, and yes, and thank you, and I think I should stop sharing, and thank you for this opportunity, and yes.
Thank you,
Sir.
Prabhadu. It's
Hello. Sir, can you hear me? Hello. Hello. Yes, sir. Can you hear me?
Yes, Prabhu, thanks for a nice session. As I said, I was just shuffling from here and there. One more NITTT training going on. Just shuffling here and there. I couldn't able to listen the entire session. Here and there I listened. It was a nice session, and I request to answer for any students. If you have any queries, please raise your hands, and the host can unmute them and ask them to let us share raise their questions. Sendil, if you want to say something, please share it, because I didn't listen. Hope you can listen to the entire thing. Ijaz Ali, someone is raising their hand. Someone should. Sendil, are you there?
hello.
Yes, Adil, please make the participants to raise their questions,
Yes, sir. Yes, sir.
because I'm just
I
using
think
mobile.
two of them have raised their hands. I have seen.
Yeah.
I think they lowered it now. There's no attendance.
No one is there.
No one is there. Okay.
Any questions from the student side? If you have questions, please share it in the chat box.
Before that, Prabhu, it's so pleasant in listening to you for almost 30 to 40 minutes. So soft spoken and best with more informations. I'm so happy to see you presenting like this after a long time.
Thank you.
My hearty wishes,
Thank you.
Prabhu. And actually, I
Thank
was
you, sir.
about to
Thank you
ask
so
one question. You also mentioned in your speech about the activities you participated during your college days. It could be a seminar or a workshop or a conference. Even one conference you have mentioned also. It was ICRAMET 2016. You are presented your papers. Your batch has presented papers. Okay. How far these kind of
Yes,
an
sir.
activities help you a lot to build up your career? This will help your fellow juniors.
Yes, sir. Actually, what I personally believe is we should attend the conferences, because what I think is because these conferences actually build up your CV, and not only that, attending a conference in a foreign is not easy, because like we have to pay some money. We have to attend some conferences in any of the foreign universities. Like we'll be paying some 20,000 for a conference, so which is like a very high. But in India, at present, like in AVIT, we get the conferences like for a very little amount or maybe for free, and this is actually a very good encouragement as far as this is concerned. And not only that, the conferences actually like builds the prospect of understanding anything, because a lecture in a class is like a minimum thing which actually the student acquires for the exam and all. But what I personally feel is a conference is actually build a person point of view and all.
Thank you, Prabhu Raidu. The activities,
Thank you,
whatever
sir.
you have done, is still wet. Some of your fellow juniors are trying to match your walks. Let us hope.
Sendil, now it's time is there. We can give that is vote of thanks, official vote of thanks. We can wind it up. Sorry, Prabhu. Actually, next
Yes,
session
it's
is
okay,
going
sir,
to
it's
start
okay.
at 4 p.m. As I said.
So only one student has
Okay,
raised
sir.
answer. We will
Please.
Shazad.
Please make it fast, Shazad. We don't have
Yes,
much time.
sir. Yes, sir. Sir, my question is, while smart sensors have already reduced the work of maintenance engineer, and AR and VR also developing rapidly, will be affect the job opportunity for a maintenance engineer in future, sir?
Yeah, of course, it's a very good question. So what I personally feel is yes, if we are not going to develop with the things, then definitely it's going to affect. But I don't think for example, let us imagine a very small production company. So it is they won't be able to afford the artificial intelligence and all for the maintenance and all. So and in those cases, yeah. But what I personally suggest is we should always go with the things of artificial intelligence. For the development of maintenance. So mostly it is very common case in foreign countries like in Europe. So it is not like always working hard, and we always find the ways to make the things easier.
Thank you, Prabhu
So,
Raidu.
Yeah.
Now, thank you, Shazad, for your question. For
okay,
further
sir.
You
questions,
just
we will
share,
have attention.
Prabhu, you share your mail ID in the there is a chat box, so that if any queries is there, persons can mail to you.
Yeah. Okay, sir. Okay, sir.
Over to Kashmir. Mr. Anthony Kashmir, please propose vote of thanks and let us wind up the sessions.
Thank you, sir. It is my immense pleasure to convey a vote of thanks. First of all, I like to thank our Chancellor, Vice Chancellor Madam, Director Research, Principal Sir, Vice Principals, and our beloved HOD for conducting this International Alumni Lecture Series. This is the second day. At last, I like to thank all my faculty members and students for attending this remarkable alumni event. Thank you, one and all present here. And once again, tomorrow will be the third day even for International Alumni Lecture Series. The topic is role of engineers in mining sector. It has been presented by Mr. Jay Ganesh, project manager, Stark Trade Private Limited. He is from 2012 to 2016 batch. Thank you, sir.
Special thanks
Thank you.
to
Thanks.
Prabhu Raidu for that is joining us and
Thank you,
giving
sir.
an
Thank you, sir.
excellent speech and motivation to the students. I request all the
Thank you,
participants to join us early. Tomorrow we are preponing the meeting 2:45 because another meeting is scheduled at 4 o'clock. We don't want to take much risk at the last minute. So 2:45, join us for that is a nice session with respect to role of engineers in mining sector. Okay. Even if any of your friends are doing civil engineering, also can join the lecture. Thank you. Thank you, Prabhu. Thank you. Thanks a lot.
Sir. Thank you, sir. Thank you.
Sam,
Bye,
you can
everyone.
close
Thank
the
you.
Sam, you can close the meeting. Thank you.
Yeah, thank you, sir. Thank you so much, sir.
Sorry, Sam.
It's okay, sir.
Prabhu Raidu, thank you very much.